Welcome to Geometry Lesson 6.7, Perform Similarity Transformations. So looking at similarity transformations, the main thing that we want to keep in mind, transformations simply mean changing a shape, whether it's a reflection, a slide, shrinking, expanding, or so on. So today we're looking mainly at the idea of dilations, which are transformations that stretch or shrink a figure to create a similar figure. Now again, keep in mind similar figures mean that they have to simplify to the same ratio. And then the other piece we're looking at, we already talked about scale factor of similar figures. Today we are looking at scale factor of a dilation, which is the ratio of a side of the image, so any side of the image, to the corresponding side of the original. So remember, an image would be your final shape after you do your transformation. The original obviously is the original shape or figure. So figuring out dilations or transformation dilations is pretty simple once you know the scale factor. Typically, scale factor is always represented with the letter K, so we're saying K equals the scale factor. So to perform any dilation, once we know the scale factor, you simply take your x and y coordinates and multiply them each by that scale factor. So if my scale factor was 4, I would take 4 times x for my new x coordinate, and then I do 4 times y for my new y coordinate. So you simply take the scale factor and multiply it by your x and y coordinates. So if a shape has 4 vertices, you need to do this process for all 4 vertices, which is what we are going to look at in example 1. So example 1 asks us to draw the dilation of quadrilateral ABCD, and then they gave us the vertices of A, B, C, and D. They would like us to use a scale factor of 2. Now, to save space, I did not draw out this example. We'll look at a drawing in example 2, but I did do the math to show you how to calculate the new points. Now, they did not tell me how to name my new quadrilateral, so I'm just going to call it A prime, B prime, C prime, and D prime. So in order to find those new coordinates, we simply take your original coordinate. So for example, A was at 2, 1. Our scale factor was 2. So we multiply the x and y coordinates each by 2. And our new point of A prime is at 4, 2. Then you do that same process with each vertice. So B is at 4, 1. We multiply each of those by 2, and we get 8, 2 for B prime. C is 4, 1. Multiply each by 2. C prime is 8, 2. And then finally D is at 1, 1. Multiply each by 2, and you get 2, 2. So if you're given a scale factor and vertices, to find your new vertices and to draw the figure, you simply multiply your x and y coordinates by the scale factor. If the scale factor is less than 1, that means your new shape is going to be shrunk, so it will be smaller. If the scale factor is greater than 1, the new shape will be larger, so it will be blown up or stretched. So example 2, we're dealing with a triangle. Part A asks us to sketch ABC and DEF. The information they gave us the vertices of triangle ABC, and they told us the scale factor is 1/2 to get DEF. So, in order to figure that out, first thing we need to do, graph ABC. So if we look down here at the graph, just took the coordinates, A, B, and C, place them on the graph. Then the second part was to find D, E, and F. So in order to do that, you can see the math right here under A. Our scale factor is 1/2, so I'm taking each coordinate and multiplying the x and the y by 1/2 to get our new coordinates D, E, and F. Once you have D, E, F, the third part of part A, come down here and graph D, E, F. For part B, they're asking us to verify the two triangles are similar. Now we know if we're doing a dilation, all the shapes will be similar, but we need to prove that or verify that in this case. So what we want to do first, if we simply look at the two triangles, we want to think about our triangle similarity theorems. So we have side, 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 angle, side, our hypotenuse leg, or we could use the angle relationships as well. But in this case, what we're going to look at is just angle C and angle F. I know angle F and angle C are both right angles because I can tell that looking at the graph. So then what we need to check are the sides to see if those simplify to the same ratio or are proportional. So what I did is took AC over DF, AC being the bottom, DF being the bottom, and BC over EF, the right-hand side and the right-hand side. AC over DF, taking the lengths off the graph, AC was 4, DF was 2, so we have 4 over 2. Then BC over EF, BC was 6, EF was 3, so do 4 over 2 and 6 over 3 simplify to the same ratio? Yes, they do. They're both 2 over 1. So by side angle side, triangle ABC is similar to triangle DEF. So example 3 is if we need to find a missing coordinate based on a diagram. So what they're telling us in this diagram is we want to create EFGH so that it is similar to quadrilateral PQRS. They're asking us to find the coordinate that's missing, which is H. Now, when I look at that, I know my corresponding points. E goes with P, F with Q, G with R, and H with S. So I'm going to check what the scale factor is using those corresponding points. So how did I get from P to E? Well, P was at 3, 0. E was at 9, 0. So our scale factor was multiplying each by 3. From Q to F, same thing. From 1 to 3, had to multiply by 3. And then on R, 0, 2, how did we get to 0, 6? That's also a scale factor of 3. So I know my scale factor is 3. So to figure out my missing coordinate of H, I take what it corresponds with, which is S, and plug that in by multiplying each by 3. So 4 times 3 was 12, 5 times 3 was 15. So H is at the coordinate 12, 15. Then the last part for dilations is the story problem related to photo stickers. So it says we are making our own photo stickers. The photo is 4 inches by 4 inches. The image on the sticker is 1.1 by 1.1. What is the scale factor of the reduction? So because they told me reduction, I know that it needs to be less than 1 when I do my scale factor because it got smaller or reduced. So that tells me I need to take one of the sides off the new sticker because it's smaller, so the 1.1 inches, over one of the sides that's off the original photo of 4 inches. So I just set it up as 1.1 over 4. We can't have decimals in a fraction though, so I multiplied the top and bottom by 10, And I've figured out my scale factor is 11 over 40. I would recommend leaving the scale factor in this scenario as a fraction. If you wanted to convert it to a decimal, you could do 11 divided by 40 and write out the decimal. But those are the only 4 examples to go with this lesson. If you need any help as you're working on the practice problems, which can be found in Google Classroom, please shoot me an email or contact me during office hours and I'll get back to you with help.